This lesson begins the chapter 9 section on, or chapter 9 on transformations. The first section we're going to talk about is translations. In middle school math, you studied 3 topics called slides, flips, and turns. They all go under the heading of transformations. Transformation simply means to move an object. We are going to call them by their more technical names. Slides become translations. They do the same thing, but they are now going to be called translations. Flips, when you flip an object over a line, that's called a reflection. And when you rotate an object, when you turn an object, it's now going to be called a rotation. The image before you move it is called the pre-image. The original one is called the pre-image. And after you move the figure, then it's called an image. We use this symbol, it's called the prime symbol, and that is used to denote where one point goes in the beginning and the end. For example, this triangle starts out and point A is this original point. When you translate an object, you are simply sliding it. That's what you do. Okay, so if this was the way that I was translating an object, I would simply, if the arrow shows the way that I'm translating, then point A, the original point A, now becomes A prime because I've moved it. If I were to take this object then, take this object and move it, let's say a second time along the arrow line that I give you, then that would be called a double prime. That means that point A has moved two different times in order to get to this spot right here. Okay, so my pre-image would be denoted with a capital letter. My first image would be denoted with a single prime symbol, and if I moved it after that, I would add an additional prime symbol every time I moved it. All of the movements that we are going to talk about in this all 3 of these that we're going to talk about in the first half of this chapter are called isometries. They're called isometries because that means that the original image and then the ending images are all congruent to each other. The object does not change size or shape. It changes position, it moves somewhere else, but it remains congruent to the original. And so if it remains congruent to the original, it is called an isometry. The last vocab word that we are going to talk about is a composition. Composition of transformations is simply doing more than one transformation to the same object. For example, in order to get to A double prime, I had to translate here and then translate here. That would be called a composition because I did 2 transformations in order to get to this spot right here. So 2 prime symbols would denote a composition. But anytime the figure moves 2 different times, it is called a composition. And you can combine them. It could be a slide and then a turn. It could be a slide and then a reflection. It could be any of those. You could translate, rotate, translate, reflect. You could rotate and reflect. Any combination of 2 or more is considered a composition. The term glide reflection is the most common one. Glide means you slid it somewhere, you translated it, and then you reflected it over a line. So let's work on figuring out how to make an object slide or translate across your paper or your computer screen or whatever. Most of the translations that we do are going to be done on the coordinate grid, which means that each one of our points will have x, y coordinates attached to them. And you doing them that way allows us to have a rule to follow, okay? All of our rules, and we're going to use rules with rotations and reflections as well, but all of our rules are written in what's called rule notation, which means you start with the idea that everything is made up of x and y coordinates. So every coordinate, every piece of our object has an x and y coordinate that goes with it. Okay? The arrow infers that you are moving it, and then the rule itself tells you how to move it. In terms of translations, we will be adding or subtracting to each of our x and y values. That's how translations work. When you slide an object, you have to add or subtract from the x, and you have to add or subtract from the y. That will tell you how far you slide it, how far you translate it, and in which direction you translate it. So to look at this, do you remember on the coordinate grid, which directions do the x values go? When you are on a coordinate grid, this is your x, excuse me, axis, so your x runs left to right. So if you add a value, if you start at 1 and you add a value to your x, you move to the right. If you subtracted a value from your x, you would move to the left. So the general rules are that if you add something to your x value, you're going to move to the right. If you subtract something from your x value, then you're going to move your object to the left. The y works basically the same way, except that the y-axis goes up and down. So if you're starting at an object and you want to move it up, you would have to add something to your y value. And if you are moving down, you'd have to subtract something from your y value. So the general rule is that if you have y plus a number, that means it's going to move up. If you have y minus a number, that means you're going to go down that many spaces. So our first example, here's our rule. And a lot of times they put a capital letter here. A lot of times, like this one might be a T because it's a translation. In your homework, they'll specifically not use T's or R's because they don't want you to know whether it's a translation or a reflection. They'll purposely use random letters, A's, B's, C's. But just know that that's part of the rule notation. Okay? It means that you take your x and y values and you're going to move them by adding 3 values to x and subtracting 2 values from your y. Okay? So adding 3 to the x, adding tells you you're going to go to the right. So that means that every coordinate point that you're working with is going to go to the right 3 units. And then every coordinate in that picture is going to, since you're subtracting 2 units from the y, means you're going to go down 2 units. So overall, you would describe this rule in words as you would translate right 3 units and down 2 units. Okay. So what happens to it when you have individual points that need to follow this rule? You simply plug them in. Okay. 4, 3 becomes, well, you take 4 and you add 3 to it. So 4 plus 3 is 7. And 3, the y values, you subtract 2. So 3 minus 2 is 1. So the point 4, 3, using this rule, becomes the point 7, 1. 4, 3 moved to the right 3 units and down 2 units to go to 7, 1. You can go the opposite direction. If I give you the rules in words, you can write them and then use them the same way. So if you have that you need to translate a figure 4 units to the left and 1 unit up, when you go to write that rule, you write that x and y move, and then what do you have to do to the x to make it go to the left 4 units? You would subtract 4. And to go up 1 unit means that you have to take your y value and you'd have to add 1. Minusing 4 will make it go to the left 4 units, and adding 1 to the y will make the object go up 1 unit. Excuse me. A second option, or a second round here, if you take and do a second translation, and this one would be up, or excuse me, left 2 units and 3 units down, then you'd write the rule for that one. So again, to make it go left 2, you'd have to subtract 2. And to make it go 3 units down, you'd have to subtract 3. Now, to bring back the vocab, this was a translation, and this was a second translation. So if I were to put these together, it would be called a composition. And since they are both translations, you can combine them into one rule that would represent both combinations. So for each x value, first I subtract 4, and then to go to the next one, I would have to subtract 2. So if I subtract 4 and then subtract 2, my composition would be to ultimately subtract 6. With my y values, I added 1, and then I turned around and subtracted 3. So ultimately, where am I going from beginning to end? I would add 1 and minus 3 means that in total, I'm going to minus 2. So this would be the rule for the composition. These would be the rules for the individual translations. That is the end of this lesson. Your homework is as follows.